To find the horizontal asymptotes of f of x equals the square root of x squared plus 1 minus x, we should recall the definition of a horizontal asymptote. We say that the line y equals L is a horizontal asymptote of a function if the limit of the function at positive or negative infinity is equal to L. So to find the horizontal asymptotes of this function, if it has any, we need to evaluate its limits at positive and negative infinity. In this case, we only really have to worry about positive infinity, because if we imagine x going to negative infinity, this is going to get arbitrarily large, and then we're subtracting an arbitrarily large negative number, so in fact we're just adding an arbitrarily large positive number, and so it's clear that this diverges to positive infinity as x goes to negative infinity. So no horizontal asymptote there, but we do need to evaluate the limit as x goes to positive infinity as well. So it's clear that as x goes to negative infinity, this function gets arbitrarily large. But what about as x goes to positive infinity? Well, to evaluate this limit, you may consider using the conjugate. We have the square root of something, and plus or minus something else, and so if we multiply this term by its conjugate, what we're going to get is the difference of the squares. In other words, we would eliminate that square root, and as you'll see, this will allow us to evaluate it. The conjugate of a minus b is just a plus b, so what we're going to do is multiply this term by its conjugate over its conjugate. That way, we're really just multiplying by 1, but you'll see this changes the form of the expression in a useful way. So we multiply by the square root of x squared plus 1 plus x divided by the square root of x squared plus 1 plus x. Now, in the denominator, we're just going to leave that conjugate. But in the numerator, we have this times its conjugate, which will just produce the difference of the squares. The square of this term is x squared plus 1, and the square of this term is x squared. The fact that there's a minus and a plus is what causes the middle terms to cancel out. We would have this times positive x and this times negative x. Those things go away, so that's all we have in the numerator. You can see that x squared and minus x squared will cancel out, and we're just going to be left with positive 1. So now we have the limit as x goes to infinity of positive 1 divided by that conjugate term. All we have to do now is divide the numerator and denominator by x, and it will be clear what this is approaching. Dividing 1 by x produces 1 over x in the numerator. In the denominator, x divided by x is just 1, and since x is positive, x is the same as the square root of x squared. So when we divide this square root term by x, we can bring that division into the square root as a division by x squared. X squared divided by x squared is 1, and 1 divided by x squared is 1 divided by x squared. Again, the fact we're using here is that if x is positive, which it is because it's going to positive infinity, then x is equal to the square root of x squared. So to divide this square root term by x, we divide its inside by x squared. That gets us here, and now it's clear as x goes to infinity, this term approaches 0. This term also approaches 0. And so what we're left with is 0 divided by the square root of 1 plus 1, which is 0 over 2, which of course is 0. And so y equals 0 is the one horizontal asymptote of this function, which we can see in the graph. As x goes to negative infinity, the function just goes to positive infinity, as we discussed. But as x goes to positive infinity, we can see that the graph is approaching that horizontal line y equals 0. And so that is the horizontal asymptote. Here's another similar example you can try. In this example, x going to positive infinity is clearly going to make this function diverge to positive infinity. So the limit we have to consider really is when x goes to negative infinity. Clearly, this expression is similar to the last one. We have the square root of something plus something. So again, we're going to use the conjugate. We'll multiply and divide by the conjugate of this expression. So that looks like this. The conjugate of the square root of x squared plus 3 plus x is the square root of x squared plus 3 minus x. Now we're going to leave that conjugate in the denominator, but in the numerator, this times this, those are conjugates, and so it just produces a difference of squares. The square of this term is x squared plus 3, and the square of this term is x squared. Just like in the previous example, we see that x squared and minus x squared cancel out and just leave 3 behind. So now we are here, and just as in the previous example, we want to divide the numerator and denominator by x. In the numerator, 3 divided by x is 3 divided by x. In the denominator, minus x divided by x is minus 1. But as for the square root term, this time we have to understand that x is negative because x is going to negative infinity. So in this case, x is equal to negative square root of x squared. So to divide this square root term by x, we're going to divide it by negative square root of x squared. Thus, we have a negative outside of the square root, and then we can bring this x squared in the square root with division. So we'd have x squared divided by x squared, which is 1, and 3 divided by x squared, which is 3 over x squared. Again, notice that we have that negative outside the square root. And so both of these terms in the denominator are negative. So let's just take that negative out. Taking that negative out of both terms in the denominator and just moving it to the numerator to make this a little more clear, we see that as x goes to negative infinity, this term in the numerator is going to go to 0. This is going to go to 0. And so what we're going to be left with is 0 over the square root of 1 plus 1, just like before. This is 0 over 2, and so the limit is 0. Hence, the horizontal asymptote of this function is y equals 0. We see in this graph that as x goes to positive infinity, so too does the function. But as x goes to negative infinity, the function is approaching 0 as we expect. That is the horizontal asymptote. So those are a couple of examples of how to use the conjugate in order to find horizontal asymptotes of some functions with radicals. Let me know in the comments if you have any questions, and be sure to check out my Calculus 1 course and Calculus 1 exercises playlists in the description for more. Thanks for watching.
Stressed out, sweetie, I'm stressed out. Sounds like you've been stressed out. Tell me what you're stressed about. Stressed out, honey, I've been stressed out lately. Don't know what's what, don't know what I'm stressed about. Stressed out, sweetie, I'm stressed out. Sounds like you've been stressed out. Tell me what you're stressed about.